Good day to all. In this GPRS overview course, in the first module, we will discuss the architecture and overview of the GPRS network. First slide shows the data communication models. As we already know, the two models, we are almost familiar with the two basic models. First one is the circuit switched and packet switched. Before we move towards the GPRS, let us have a quick recap on these two techniques of data communication. First one is the circuit switch. In this mode of communication, a user is first assigned a dedicated resource. In this case, GPRS or GSM, what will be the dedicated resource? It is a physical time slot. And this resource remains permanently to the user till the user disconnect the connection, and user will transmit and receive data on this resource either continuously or in breaks depending on the application, right? So in this method, resource utilization is on the time basis. In the circuit switch, resource utilization is on the time basis and hence reduces the number of resources for data call. As a result, it reduces the subscriber capacity of the network. Rather, in the packet switch, in this mode, resource is only assigned to the user when data needs to be sent or received. Hence, data in this packet switch mode increases the data subscriber. Since the same time slot or physical time slot resource can now be shared by multiple users. And this technique is quite effective in capacity and resource management. But on the other hand, has some limitation on data throughput. Here we can see some adjustment in the GSM network architecture. We can see here the BSS radio access network part and the CS core network part. The interface between BSS and CS core network is A interface. Sometimes A interface is also known as backhaul. And one of the unit that is added in the radio access network, or we can say BSS, that is the PCU, packet control unit. And in the core network, a pure packet switch core network is added in the NSS part. In this PS core network, additional PS core network is added in the GPRS network, that is the SGSN and GGSN. We will discuss in the subsequent slides. And the interface between this PCU and PS core network, that is the GB interface. G stands for GPRS. The migration from GSM to GPRS and then UMTS are shown here. To transition from GSM to GPRS requires the addition of new hardware and software. New hardware elements, what it includes: GGSN, SGSN, and PCU. GGSN is the Gateway GPRS support node. Gateway GPRS support node. And the SGSN is the Serving GPRS support node. And the PCU is the Packet Control Unit. Here we can notice that the voice call still go through the GSM circuit switch network using the MSC, but data calls are routed through the new entity in the RAN or BSS, that is the PCU, then SGSN, then GGSN, and on their way to the internet or external network. We will include the UMTS diagram for completeness. It is just a covered in more detail in another paper or course. Just note that a new set of network elements is added to provide the higher speed data services. That is the UMTS RAN include the node B, and RNC node B is the base station of the 3G, and the radio network controller part in place of BSC in the GSM network. Here we can see here the some highlights of GPRS, General Packet Radio Service. GPRS stands for General Packet Radio Service. We will discuss on this slide the key highlights and differences which GPRS brings in on existing GSM. First, GPRS is nothing but using existing data communication technologies and network to achieve data communication applications like internet, intranet, email, right, etc. Since GPRS has the end users has a mobile phone, hence this brings in several changes to the access network. So GPRS works and sits on the existing GSM network and allow the GSM users to achieve packet communication, right? And the GPRS uses the packet switch data. This means no dedicated circuit switched need to be assigned to a mobile. A physical channel is only assigned when the data transfer is required. As a result of this, one resource or time slot, physical time slot on the air interface can be shared by the multiple users. Hence, the multiplexing of several users on limited and fixed resources. The packet switch data, when leaves the GSM network, is received by existing outside world, that is the TCP/IP network like internet, intranet, or previously known as the X25 network, etc. Hence, GPRS provides the interworking protocols for working with standard external packet data network. GPRS phones also requires to handle the both GSM and packet switch communication, or circuit switch as well as packet switch communication. Hence, the existing GSM phones cannot be used for the GPRS service. In that era, GPRS has a new transmission techniques and interworking with IP word, and this allow the new transmissions and the signaling procedures to be introduced in the existing GSM network. GPRS, here we can see here the also supports high data rate. This is done by changing the air interface error coding scheme and by using the multiple time slot. Here we can use maximum 8 time slot if GPRS phone supports, right? And different coding scheme. What is the different coding scheme used in the GPRS? That is the different kit, that the coding scheme 1, coding scheme 2, coding scheme 3, coding scheme 4. In the short, we can say the CS1, CS2, CS3, CS4. Right? Similar to high-speed circuit switch data, we can get the maximum of 171.2 kbps data rate theoretically by using the 8 time slot. If one subscriber has given to all the 8 time slot, then the maximum theoretical data rate will be 171.2 kbps. This practically at this stage looks impossible due to design challenges of mobile phone and quality of air interface due to spectrum limitation and use of packet switch communication allow the non-continuous assignment of resources to a user. Hence, billing does not occur on the time basis. The most of the traffic for GPRS usage will be based on the volume basis, or we can say usage basis. Then billing based on the throughput or volume basis. GPRS has also provision to support SMS. In the existing GSM system, SMS is transport on the SGCCH channel. Hence, it congests the SGCCH for voice usage at the air interface. Here, some more details are shown in this slide. The different interface between the different nodes. We can see here the new GPRS network elements are at GGSN, Gateway GPRS Support Node, and the SGSM, Serving GPRS Support Node, and the PCU. Each of these will be described in different interface. Some of the new interface you can see here then include the GB interface between the PCU and SGSN, GN interface between the SGSN and GGSN, and the GI interface between the GGSN and public data network. And some more interface we can see here, the GS interface between the packet switch and circuit switch core network terminal, that is the SGSN and MSC. VLR, GC interface between the GGSN and HLR is optional actually, but uses the MAP protocol. And GD interface between the SGSN and SMSC. And GR interface between the SGSN and HLR, it is extension of MAP. Right? So these are the some interfaces introduced in the GPRS network. Let us try in this slide the different brief functionality of the GPRS block. First one is the PCU, second one is the SGSN, third one is the GGSN, right? And the GGSN connects to the external network via the GI interface and can act as a firewall to prevent the unwanted access. Right? The prime function of the GGSN will be route the incoming packets of data to the appropriate SGSN, which is supporting the wanted mobile stations for the packet. The GGSN also needs to support some billing functionality like counting of data packets per connection CDR, and also GGSN is responsible for providing the IP address to the mobile stations. Now SGSN, it controls the BSS and controls the mobility management functions for the GPRS phone. And the SGSN also provides the packet data service to the mobile attached on the GPS network. It manages the packet communication session between the individual mobile station and SGSN and GGSN. Sorry. The SGSN also interact with the GSM database like HLR, VLR, right? AUC database to achieve the mobility management functions and get subscription information to offer the desired service to the mobile station. What is the mobility management functions? Like paging, routing area update. These are the main mobility management functions. Other than mobility management functions, it also handles the session management. Now the PCU, the packet control unit, take care of radio resource functionality like allocation of air interface channel blocks. It will also do the packet segmentation due to limitation of bandwidth on the air interface. The PCU also looks some quality of service measurement to alter the communication parameter on the real-time basis, but not much more quality of service here in the GPRS network. Now, thank you to all. We will be discussing, continue that in the next module. Next module will be the call flow of GPRS in brief. Thank you to all.